if you have a geometric sequence that is considered infinite. Remember, a sequence that is infinite continues on forever. A lot of times you'll see that ... which means it's going to keep on going forever and ever and ever. Well, how are we going to know if it converges or diverges? Well, if your common ratio R is between -1 and 1, not including -1 and not including +1, but if it's somewhere in between -1 to 1, that means it's a proper fraction where the top is smaller than the bottom, or a decimal that's smaller than 1 or -1. So it could be positive or negative. All we care is that it's smaller than 1. Then it will converge, definitely, if it has that kind of R. And what's it going to converge to? That's what this thing says. It says the infinite sum. That's why it's got an S with a little infinity sign. The infinite sum will be given, the actual number it's going to converge to will be this formula right here. And yes, I would make sure that you know it. The formula says that you take the first value in your sequence, your a sub 1, and divide it by 1 minus R, your common ratio R, and this will be what your sequence is going to converge to. It may not actually end up being equal to that value, but it's going to get closer and closer and closer. That is what this LIM thing means. It stands for limit. If you take a calculus course, you'll see this more. And again, the idea is as you plug in bigger and bigger and bigger numbers, you get closer and closer to a specific number. That's what it means for something to converge. Now, what if your R doesn't look like this? What if your R is not between -1 and 1? Well, if it's not, then we're not even going to worry about it. We're going to say our series is going to diverge.